Okay, now before we look at this question proving the identity, we go and look at this couple of this for the sake of Shawn. Now, sine theta over cosine theta is actually equal to tangent theta. Okay, this can be proven if let's say this is theta in a right angle triangle. You got A, you got B, you got C. So sine theta is actually basically A over C. Cosine theta is B over C. So this cancel out. This is actually equal to A over B. Okay. A over B. But if A over B is actually equal to tangent theta. Okay. Now the next one would be how to prove sine square theta plus cosine square theta equal to 1. This is the mother of all identity. Okay, this is mother of all identity. This is the starting point. How you proceed and develop the other two identity. Okay, now sorry, identity means there is a three line here. Okay, now let's start off with same using this. Sine square theta basically is A square over C square plus cosine theta actually is B square over C square. Okay, since they have the same denominator, which is C square, we can combine them. So it's A square plus B square. Now A square plus B square, actually you look at this is a right angle triangle. A square plus B square actually equal to C square. So C square over C square is simplified, you get a 1. Okay, now then you have therefore you have this side square theta plus cosine square theta equal to 1. This is the first identity. Remember, put a 3 line instead of normal 2 line, which represent the equal sign. This represent the identity. Now you divide sine square theta divided by sine square theta divided by sine square theta. This cancel. You got 1 plus. This one is cosine square theta divided by sine square theta. Basically, it is cotangent theta square. And then 1 over sine square theta, basically it is cosecant theta square. So this gives you the identity. This is the first one. Then this is the second one. Okay. Now let's go to the third one. The third one basically, instead of divide by sine square theta, you divide it by cosine square theta. Okay. Now, so I divide by cosine square theta divided by cosine square theta divided by cosine square theta. This one become a tangent square theta. This cancel become 1. 1 over cosine square theta is actually secant square theta. Okay, therefore this gives us the third identity. Okay, now so we're going to use these three identity to prove the left side equal to the right side. The rule of simplification is you always take the more complicated one side and you simplify it to be same on the other side which is less complicated. Okay, now if you compare number 1, sin theta cosine theta is equal to cosine theta, this definitely is more complicated. So what you have to do is you take this side and you simplify it so that it becomes like that. Okay? Now, what about this? This to the power of 4 to the power of 2. This to the power of 2, 2. But which side is more complicated? Now, this is actually, this time, this considered as one term, but this one is actually 2 term. This term minus another. So, this one is considered more complicated. Okay? Like, for example, question 12, obviously the left-hand side of the equal sign is more complicated. Okay? Now, question 14. Okay? In this case, I would say this is more complicated, the right-hand side here. Okay? Now, let's start off with a more simple one, like this one. We want to prove. Okay, so let's say question 3. Question 3. The left-hand side. Let's look at the left-hand side. So it is 1 plus tangent square theta 1 minus sine square theta. Okay, now so we're going to proceed and prove this as we simplify, so end up with 1. Okay, now let's start off with you can use the identity here. You got a tangent, okay, square, or you can convert this sine square theta into cosine. Okay, over here is square term, so now let's look at this. Okay, if I move the sine square theta over to the right hand side, so cosine square theta is actually equal to 1 minus sine square theta, right? So 1 minus sine theta square, okay? So it's equal to cosine. So this term, 1 plus tangent square theta, okay? This one actually can be replaced by cosine square theta using this identity. Okay, now let's look at tangent. Now, tangent 1 plus tangent square theta is this, okay? Is equal to secant square theta. So this whole thing, this bracket can be replaced by secant square theta times cosine square theta. But we know that secant square theta is actually 1 over cosine square theta times cosine square theta. So cancel, become 1. And this is equal to the right hand side. Therefore, you have proof. You have proof that the right side or the left side is exactly the same as the right side. Okay? Now, let's look at question number 1. Question number 9. Okay? If you look at it, this is 1 term, this is 2 term. me, this is more complicated because it contains a two term. Okay, so I'll the left hand side of question 9, which is tangent square theta minus sine square theta. Okay, I'm going to convert this so that it looks like this. Okay, another point is sometimes you have to look at the right hand side. Okay, this one got to the power of 4. Okay, so how will you get? You see, sometimes to give you some clue, what you can do is you even simplify the right hand side. For example, sine 4 theta times secant is actually 1 over cosine square theta. Okay, so this is actually equal to sine square theta over cosine square theta times again sine square theta. So sine square theta times sine square gives you 4. This one actually equal to tangent square theta times sine square theta. Okay, this just to give you some clue. Now, how will you convert this? Okay. Now, what you do is you split the tangent into sine and cosine square theta minus sine square theta. Okay, now, wait, sorry, square here. Let's take out a common factor, which is sine square theta 1 over cosine square theta minus 1. So this sine square theta, let's combine the two fractions. So you got a cosine square theta 1 minus cosine square theta. Okay, now 1 minus cosine. So if you bring this over here 1, you bring the cosine square theta to this side. So it's 1 minus cosine square theta, which is exactly same as this. And actually, if you bring it over, what remains is sine square theta. So basically, it becomes sine square theta times 1 minus cosine square theta is actually becomes sine square theta over cosine square theta. Okay, now, so we have sine square theta times sine square. So this is basically sine 4 theta times. If you take this and put over here, so this ends up with 1 over cosine square theta, which is actually secant square theta. So this is exactly same as the answer here. Therefore, it's equal to the right hand side. And then you have proof. Past tense, you have proof that you have managed to prove that the left side is actually equal to the right side. Okay? Now, let's look at the harder question, maybe. 16. Okay? Cosecant theta minus cotangent theta square must equal to 1 minus cosine theta 1 plus cosine theta. Okay, Now, if you look at the trigo here, this cosecant, this cotangent, this, and you have a square here. So here seems to be more complicated than this, because this is basic cosine only. Okay, but this one got cosecant, got cotangent, somehow you have a square. So we're going to take the left hand side of the equal sign and we're going to simplify it. So it's cosecant theta minus cotangent theta. Okay? Okay, now you can actually expand this. If you expand this, what you're going to get is cosecant square theta minus 2 cosecant theta times cotangent theta. Oh no, this wrong step. Okay, now let's open it up to the basic angle first, sine, cosine, tangent. Okay, so this one is actually 1 over sine theta. This one actually is cosine theta over sine theta squared. Okay, now, so we're having the same denominator, so we can actually add the numerator. So 1 minus cosine theta over sine theta square. Okay, therefore there's 1 minus cosine theta square over sine square theta. Actually it's split the fraction. Take the power of 2 for the numerator and take the power of 2 for the denominator. Okay, now so it's 1 minus cosine theta square sine square theta. You go back here, sine square theta is actually equal to, bring over, so it's 1 minus cosine square theta. Sine square theta is actually equal to 1 minus cosine square theta. You bring this over. So this can be written as 1 minus cosine square theta. Okay, now let's proceed from here. Let's look at this identity. One square minus cosine square theta. Okay, this gives us the case of a square minus b square is actually equal to a plus b, a minus b. Okay, so this one can be written as 1 cosine theta square over 1 plus cosine theta and 1 minus cosine theta. Okay, now 1 minus cosine theta square is 1 minus cosine theta 1. So actually you can cancel this with this. These two, there's two, the same value multiplied by itself. So I cancel 1. So what remains will be 1 minus cosine theta over 1 plus cosine theta, which is actually equal to the right hand side, and we have proved it. Okay, that's it.